Well, hey everyone, and welcome to another episode with your girl Audrey Codner. Doing some math. All right, so last night we were adding, we were subtracting, we were multiplying radical expressions. Can't even speak. So now we're going to work on dividing. So we are going to be taking this step by step. Now, with dividing, there's some rules. Yeah, just like everything in life, rules. So we have four things that you have to keep in mind when you are dealing with dividing of radicals. I don't know why this keeps sliding over. Here we go. All right, so rule number one. No perfect squares underneath the square root. So anytime you see that square root and there's a perfect square, go ahead, simplify it, right? No fractions under the square root. So we're not going to leave our answer with, like, say, a square root of 1/4. No, we're going to simplify it, and we're going to have to do something which is called rationalizing the denominator, just in case that denominator, the square root in the denominator, is not a perfect square root. Now, number three, no radicals in the denominator. I was just saying that, right? So we're going to do what's called rationalize it, and I'm going to show you what that looks like. And then the last one, always look to reduce your answer, all right? So if you think you have it all packed and said and done, you might be able to simplify it some more. So like if I said I had the square root of 12, I know I can break down the square root of 12 with the square root of 4 and the square root of 3, which will give me 2 radical or square root of 3. So let's get our division on before we get right into it. So I know I'm going to insult your intelligence, but just work with me. So 6 divided by 3, that will give me 2. I know, mind-blowing. Are you losing it? Hey, that's fine. But what we did was we took a whole number divided by a whole number to get a whole number. So now we have the square root of 6 over the square root of 2. This is not equal to, say, 3. That's not possible, okay? But we can't have a square root in the denominator. So what we do is we try to create a perfect square root in this denominator in order for that radical to cancel out. So if I think about it, the closest perfect square that's close to 2 would be 4. So I know if I multiply this by the square root of 2, whatever I do in the denominator, I'm going to do in the numerator. And for those that weren't here last night, I did a little shortcut. Because in my denominator, I have the square root of 2 times the square root of 2. So 2 times 2, that'll give me 4. And it's actually going to be the square root of 4. Okay? Up in my numerator, I have the square root of 6 times the square root of 2. Since they're both radicals, I can actually multiply them and get the square root of 12. But now, in my denominator, I got a perfect square root. So the square root of 4 is just simply 2 without a square root. So we already knocked out this rule of no radicals in the denominator and no perfect squares underneath the radical. So we knocked a couple rules out here. But we need to look at rule number 4. Rule number 4 says always look to reduce the answer. So if we look at this square root of 12, it's funny, I just mentioned that as an example. I can break this down with the square root of 4 and the square root of 3 because 4 and 3 is what's called a perfect prime combination. Because then I can break down the square root of 4, which gives me a whole number of 2. And the square root of 3, since that's prime, if I can't break it down, I bring it down. And then I put it over the whole number of 2. So now, with this, I have 2 divided by 2. These two are whole numbers. And when I divide them, they cancel out to give me a 1. But in this instance, I don't have to put the 1 because the 1 is always understood because there's one radical here. But that radical is going to be of 3. Okay. So because, if I unzoom just a bit, or a lot, okay, so when I look at my original, the problem was square root of 6, that's not a perfect square root. Square root of 2, that's not a perfect square root. So I had to get rid of this radical in the denominator. So I basically used that square root of 2 multiplied to itself. So whatever I do in the denominator, I do in the numerator as well. So now square root of 2 gives me square root of 4. And then 6 times 2, that gives me 12. So I got the square root of 12. Now I know some people could probably say, well, Audrey, right here, you could have done something else. And what that something else is, they're both underneath the same radical. Let me zoom. So since they're both under the same type of radical, which is a square root, I could rewrite this as the square root of 12 divided by 4. Because, oh, well, Audrey, you can't have a fraction underneath the radical. 1 second. 12 divided by 4, that could be divided, which gives me 3. Notice that gave me the same answer as the first time I'm doing it. Okay, good. Thank you, Jerry. All right. So it's like we have different ways of kind of approaching to get the same answer. So some people probably could have said, well, if we could do it there, why not? Here's way number 3. Why couldn't we just do it from the very beginning? Why couldn't we just put the 6 over 2 under 1 square root and then get our square root of 3 then? You can do it that way as well. So isn't math fun? Can you radical my expression? Aw, vavoom. You're cute. All right. So here's the thing. We have options. So either you can multiply, then simplify. That's what we did for the first time. Or you can put them underneath their own radical and then simplify. Or from the very beginning, you can put them in their own radical, divide, and get your answer. Me personally, I'm lazy. This is where I was going to go. Like, I am not even going to sit here and try to lie to you, right? This is the route that I would have gone. All right, so let's try a different one. So let's look at... Let's go with another example. Thank you for everyone that's coming and sharing. Hey, Lynette. How about the square root of 6 over 2? Why is statistics so hard? I know. Yeah. I'm sorry. Yeah, that's why I do not tutor stats whatsoever. Okay? So we have the square root of 6 over 2. Now, we're looking at our rules. Let me do a little slide. All right? Do we have a perfect square underneath that radical? Nope. Do we have fractions underneath the radical? No. Because this 2 and the 6 is not, the radical is not embracing both the 6 and the 2. Like this one. This radical is embracing both the 6 and the 2. Okay, this one is not. All right, when I say embracing, that means it's coming down to the 2. It's including the 2. Right now, the only thing that's underneath the radical is the 6. All right, do we have a radical in the denominator? Nope. All right, looking to reduce. Could I reduce it? No. I cannot say 6 divided by 2. Okay, the only thing that was different with the previous one is because the 6 had its own radical and the 2 had its own radical. All right, this time it's just the 6 that has its own radical. So guess what? That's at my lowest term. That's completely done. Okay, I can't do anything else with that. All right, any questions so far? Thank you so much for the following, guys. I appreciate it. Because, hey, final exams will be here before you know it. Some people are going to be taking the ASVAT. Some people are going to be taking their GEDs, AccuPlacers, all those examinations. And even the T's, capital TEAS, like for people that want to do nursing, the algebra piece, they will throw 1 or 2 of these radicals in there as well, okay? So just be cautious. Yep. Hey, Richie Red, there you go. All right, so now I'm going to do, let's say, one more like this. So I'll put it right here. So we're going to get our example on. I'm going to separate a little bit, just give us some room. All right, so if I had 12 square root of 6 over square root of 2. Okay. 12 square root of 6 over square root of 2. What do you think my answer will be? Okay. Oh, hey, pretty brown eyes. How are you? 24. Hey, Allison. How are you? Okay. So we got 12 square root 3. We have star saying 1/2. Okay. I got 4 square root 3. Is it Nana? Instead of Tanya, is Nanya? Nanya Biz. Liv is saying 12 square root 3. All right, question marks are also accepted. If you're just like, yeah, I have no idea, you could put a question mark in there. I'll take that. All right, so sorry, 6 square root 3. All right. All right, Patrick, actually finding the root symbol. Good job. 12 root 3. Okay. Think about it. Okay, it kind of gave you a little bit of a hint. Because it's the same exact thing that we got here with that square root of 6 over square root of 2. This thing up here. And then I said we can put it underneath their own square root. Which, if I just do the division of 6 and 2, I'm going to get the square root of 3. We got the same thing happening over here. Yeah, I thought I was slick. All right. So we have our 12, but it's being multiplied to that 6 over 2. We already know that 6 divided by 2 is going to give me 3. So we have our 12, and then we have our square root of 3. Okay, so that would be our answer. Hey, Lisa, how are you? All right. Okay. Questions. That's all right. That's all right. Okay. Well, thank you. I tried with my penmanship. Went to Catholic schools. Those nuns, those nuns were ruthless. That was back in the day. It was a different time, y'all. It was a different time. Those nuns, those nuns were ruthless. That was back in the day. It was a different time, y'all. It was a different time. Sorry, got a little phone call there. I swear, I think they like wait until I go live. Yes. Catholic school for the penmanship. Yep. All right. So, that's my first correct answer. Aw, you know. Why not multiply it out the same at the top? Now, question. So we could, but the thing is, this 12 is not underneath a radical. So if the 12 was underneath a radical, yes, you can multiply radicals with radicals and whole numbers with whole numbers. Okay, so here it was the square root of 6 times the square root of 2, which gave us the square root of 12. Because you had a square root times a square root, which will give you your answer as a square root. Okay, all right, so radicals with radicals, whole numbers with whole numbers. All right, let's try some more. When you're doing fractions. Someone was saying when you're doing fractions. When I'm doing fractions? When am I doing fractions? I already did fractions like 2 days ago. But we still have two radicals? No, we don't. Because what happens is I divided these two. I put them underneath one radical. Okay, so we only have one radical here. So 6 divided by 2 gives our 3, which remained underneath the square root of 3. Okay. So and then the 12, which is the whole number, is set next to the square root of 3. Okay. All right. Yeah, sometimes PEMDAS is a little tricky. There's always like some loopholes because I know from left to right, they're like, oh yeah, you got to multiply. Well, if you multiply, you can't multiply a whole number with a radical. You can put them close to each other. It's almost like I mentioned yesterday. It's like you could say, yeah, we're dating, but we're not dating. You know, like we're together, but not really fully together. Right? So we can get as close as we can to it, but you will not be able to multiply the 12 and the square root of 6 together. Okay? Right, you know? Like you're together, but you know, we just do what we do. What? What does that mean? And then you ask your friend who's in that type of relationship, and she's like, I'm like, girl, if I knew, I wouldn't ask. What is he saying? All right? So let me try another one. Oops, let me get all my pens together. Good gravy. All right, so let's look at this lovely example. So we have 7 divided by 8 square root of 7. Okay, so 7 over 8 times the square root of 7. Let's not label it. I know, right? I know, right? Feels like I'm like rearranging like cattle or something. Like, get in there. Round it up. All right. So now let me show it again. The rules. Rules of the game. All right. 1, we can't have a perfect square underneath the square root. 2, we can't have fractions underneath the square root. 3, no radicals in the denominator. And 4, always look to reduce the answer. All right? That's hard for me. I'm my big old age. Oh, that's your big old age. It's okay. We're gonna break it down. Especially like you probably just met me now. So if you watch, I think I have it uploaded. Last night's live. I think I uploaded it. Oh no, I will upload it because it was taking forever in a day. All right, you can kind of get a good gist of what's going on. So the rule that this is breaking is the radical in the denominator. In order for us to get rid of that radical in the denominator, we have to do what's called rationalizing the denominator. Okay? So basically, whatever is that square root, that's what you're going to multiply the numerator and the denominator by. Because the square root is 7. If I multiply square root of 7 in the numerator and then square root of 7 in the denominator. So what happens here? I'm going to elongate this. Trust me, everything has a little shortcut, but I'm going to show you the long way. So what happens is I can multiply whole numbers with whole numbers and radicals with radicals. So when I multiply my numerator, 7, the purple 7 is a whole number. The red square root of 7 is a radical. I can't get all close up in there, so I can't say the square root of 49. No. Because this 7 is a whole number, and that square root remains a radical. Okay, good. So now down below, I have 8, which is a whole number, but I have 2 radicals. I can multiply those 2 radicals together. 7 times 7 gives me the square root of 49. So now, square root of 49, that's a perfect square root. So all of a sudden, my denominator, I have an 8, but I'm going to multiply it by the result of a square root of 49, which is 7. Do you see a little pattern with that? If you don't, I'll point it out once we're done with this one. Okay? Now, my numerator, we have 7 times the square root of 7. Okay? This is multiplication. If you don't see a plus or a minus sign in between the number and the radical, that means you're multiplying. So now, again, I'm lazy. I always like to see where I can reduce. Remember I said for part 4, always look to reduce your answer. There's a 7 in the numerator. There's a 7 in the denominator. 7 divided by 7 gives me 1. These 2 bad boys can cancel out. And what remains is my square root of 7 over 8. Okay, so that root 7 is in the numerator, but the 2 7s here, they can cancel out. Because when you got multiplication and you start dividing, you can cancel out numbers. Okay, so you don't have to multiply the 8 and the 7 together to get your 56. And then, what does 7 over 56 reduce to? Oh, that's 1/8. And then you got your 8. Yeah, you can do that. Have fun. But again, I'm lazy. Okay, but hopefully you see where the movement is going. Okay, questions on this one? Okay, seems like as long as you follow the rules. So anytime to start it off, whatever your radical is, that's what you're multiplying the numerator and denominator for. Okay, now I mentioned this yesterday, but I'm going to bring it back because not everybody was here yesterday, right? Last night. So if I have the square root of 7, oops, times the square root of 7, I got a 7 as my result. If I have the square root of 15 times the square root of 15, I'm going to get 15 as my answer. And if I have, say, the square root of 3 times the square root of 3, I'm going to get 3 as my answer. Okay? Yes. Is that only on perfect numbers? No, it can work with anything. It can work with anything. If we're talking about this, it can work with anything. So if I want to, I can say square root of 5 times the square root of 5. What would that give me as an answer? Okay, follow the pattern. Yep, 5. Good. Excellent. Cinco. Yes. Yep. So anytime you multiply a radical to itself, you're always going to get this answer of 5. Like this last one, if I multiply 5 times 5, that gives me 25. Square root of 25 is 5. If I multiply the square root of 3 times the square root of 3, I get the square root of 9. Square root of 9 is 3. Okay? All right, so this will kind of help shave some time off of those exams by just knowing those little bit of shortcuts. All right, let's try another one. So let's say we have the square root of 21 over the square root of 15. Square root of 21 over the square root of 15. Okay, relax. She's like, oh no, I don't know what to do. Relax. Think about the previous ones. Think about our previous answers. Oh, Ham, thanks for sharing the live. And thank you for tapping, guys. I appreciate it. And for like a Friday afternoon, this is actually a lot. Thank you. Okay, so we're saying square root of 7 over the square root of 3. Lisa has 3 times 7 over 3 times 5 with the radicals. Ooh, okay. Okay, thinking about it. Alexa. I think I'll love you. What I'm so afraid of. Dum bum 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 bum. I'm showing my age right now. You have no idea what that song is. Okay. Partridge Family. No? Okay. All right. Take care, Alexa. Have a great day. All right. So we also have radical 7 over radical 5. Radical square root of 7 over square root of 5. All right, Trey. He's like, I know that song. Okay. So similar to, here I go. Sorry, I got to do a little verse. When it comes to when I was doing multiplying radicals, I said you have 2 ways of doing it. Either you could simplify, then multiply, or you can multiply, then simplify. Now I'm going to take almost like the reverse. And again, I like to show you guys options and you tell me which one works for your brain, okay? Because everyone learns differently. So if I could simplify first. I'm going to put simp. Well, maybe not though. That would be kind of weird. Okay, I'm going to say simplify. So if I wanted to simplify, square root of 21 can be 7 and 3. Square root of 15 can be 5 and 3. Okay? So this is all multiplication. If you want to put your little dot for multiplication, if you want to put your parenthesis, you can do that. Okay? Remember, if there's no addition or subtraction there, it's already assumed it's multiplication. So from here, you probably noticed that I have a square root of 3 over a square root of 3. These bad boys can cancel out. So now I have my square root of 7. Am I still in frame? Okay, good. Over the square root of 5. But remember, rule number 3. Okay, this is when Squid Games is going to come into effect. Okay? So, no radicals in the denominator. Dun, dun, dun. All right? So, this cannot be our final answer because we cannot have this square root of 5 in the denominator. But what we are going to do is we're going to multiply the numerator and the denominator by that square root of 5. The reason why we're doing it is so we can get rid of the radical in the denominator. We are rationalize the denominator. Okay, so here's our trick. Square root of 5 times square root of 5 will give us 5. But in my numerator, square root of 7 times square root of 5 will give us the square root of 35. This is your final answer. This is. Okay? I know, there's 60 million two rules. I know, it makes you crazy. Okay. Questions? Okay. Did I blow your minds completely? Okay, not a problem. Not a problem. If anything, I will be on tomorrow. I'm not sure if I'm coming back on tonight, but I'll definitely be on tomorrow. Okay? She's like, mind is officially blown. All right. So that was simplify. Okay. Remember, I like to say, I'm going to show you multiple ways. That was simplify. So if I break it up, meaning do what I did with the second one. So if I divide, so when I mean divide, that means I'm going to put both of my radicals underneath the same radical. So that'll be 21/15. Now, 21/15, that's not going to give me a nice, sweet, even number when I divide it. However, if I simplify it, 21 and 15, they're both in the 3 times table. So I'm going to divide this by 3, divide this by 3. Okay, that's how you simplify. So this will give me 7/5. Okay. Since we can't get anything out of the 7/5, that's when some people will say, all right, we'll give them their own radicals again, but now it's reduced. Multiply the numerator and denominator by that square root of 5 like we just did earlier to give our square root of 35 over 5. And I know someone out there in this known universe is going to say, hey, Audrey, could we just divide the 35 into 5? No, because that square root of 35 is underneath the radical. So since that's underneath the radical, I can't touch it. I know it's tempting. You know? I don't know how else to say. It's like you walk by a bakery and you see this delicious, delectable, succulent chocolate cake. Or whatever your favorite pastry is. For me, it's like croissants. Can't take it. But you walk by it and then the smell hits you. But you'll do anything not to walk into that store. And just, take one and walk right out. No. So it's like you can get as close as you can to it. It will be tempted, but don't do it. Okay? Yeah, you like the simplified way? So do I. So do I. Where did the square roots of 5 come from? Well, whatever your denominator is, that's in a radical. Let me see if I can unzoom just a hair. Okay, whatever the denominator, the radical in the denominator is, that's what you're multiplying. Because you always want to get rid of the negative square roots from your denominators. Okay. Okay, no problem. Not a problem. All right. Let's see if we can... Let's see if we can do a couple more. And then I'm going to try. All right, let's try one more. And then I'm going to throw some stuff at you guys. Like literally throw some stuff at you to see what works. Like how would you solve it? Okay, so you got the square root of 15 over 3, the square root of 6. Square root of 15 over 3 times the square root of 6. All right. Oh, thank you for the follow. Oh, Disco Danny, thank you for the follow. See what you can get out of it. See how you can simplify this. A little too much. Is it 5? Like as your final answer? Okay, it's not 5 as your final answer. Oh, okay. Okay, keep going, Trey. It's almost like in class when the teacher's like, oh yeah, keep going, Trey. Everybody's like, what did Trey say? What did he say? What did he say? Michael. All right, Michael is saying root 10 over 6. How are you? Happy Friday to you. I'm doing okay. Had a couple of good meetings today. Just need to find the motivation to get my next steps going. But, just doing math. Okay. All right. Going to show our answers. If you got the answer, go ahead and put it up. If you're not sure, put a question mark. And be truthful. Okay? It's not Squid Games. We're not going to off anybody. I promise. Okay. Hello, Rita. Saying 3 out of 30. Okay. Okay, don't be afraid to put up your answers. I mean, I'm not going to put a social media post and be like, oh, look at this person's answer. Like, 1, don't have time. 2, that's just rude. I really should have started with the rudeness first. I'm sorry. 1, that's rude. 2, don't have time. There we go. Okay, and you're saying it's the square root of 10 over 6. Okay. All right, you're sticking with the square root of 10 over 6. Okay, radical 10 over 3. Okay, so I got 6's, I got over 3's, over 6's. Okay. Are you looking for an answer without roots? No, keeping the roots, Vic. I'm sorry, I skipped over your thing. Yeah, keeping the roots. We want to get our answer as true as possible. I don't want to do any rounding just yet. All right, Sean's saying square root of 10 over 6. I saw root 5, 3 square root of 2, but that could be rationalized. Yes, definitely rationalize. Okay, so you have 5 root 2 over 6. Okay. All right. Love getting different answers. Root 5, root 2 over 6. Radical 10 over 6, root 10 over 6. All right, so now we have some different answers. So let's see. Lady Liberty with her rounded decimal. Good job. All right, so easiest way that I can think of, because I'm lazy. Okay, with the 4, thank you. All right. We cannot have a radical in the denominator. So we are going to multiply both the numerator and the denominator by that square root of 6. So when it comes to radical being multiplied by the radical, we can do that. We can multiply radical with radical and whole numbers with whole numbers. So we're going to have the square root of 90 over, switch up with the pens, 3 times 6. Where did I get this 6 from? Where did this 6 come from? Okay, there we go. All right, so root 6 times root 6. Okay, that will give me the square root of 36. Square root of 36 just gives me 6. Remember, if you have the same radical with the same radicand, that's what's underneath, that means you're going to get that number without the square root. So now my denominator, I'm going to have 3 times 6, which could give me 18. But hold on. Let's see what's going on with this square root of 90. So what are some factors of 90? And I would love to get it in that perfect prime combination. So if I kind of look at my handy dandy, major zoom, okay, we got our 90. So for the 90s, there it is. So for 90s, we got 1 and 90, 2 and 45, 3 and 30, 5 and 18, 6 and 15, and 9 and 10. 9 and 10, that's going to be my perfect prime combination. Perfect, which is my square root of 9. And you're probably saying, well, Audrey, 10 is not prime, but the square root of 10 is one of those special prime radicals. So if I want to, if I'm looking at the special prime radicals, that means if I tried to break down the square root of 10, I'm going to get square root of 5 and square root of 2. Both 5 and 2 are prime numbers, so I'm not going to get anything out of it to break down like a perfect square root. So instead of leaving your answers with 2 radicals in there, you know, most math people, we like to clean things up. So we keep it with that square root of 10. Okay, another example would be like square root of 6. We know the square root of 10. What else? Square root of 14. Square root of 21. And I know square root of 35 is the most famous one, but there's definitely more. Okay, because if I try to break these down, I'm only going to get 2 numbers that are going to be prime numbers. So the best bet, as you guys are saying, is going to be square root of 9, square root of 10. And we bring down the 3 and the 6. Square root of 9 gives me 3. So my numerator, I have 3 times the square root of 10. My denominator, I have 3 times 6. So I know back here, it's tempting for me to just go ahead and let me multiply. But then take a look. Once we got here, all we have to do is simplify. 3 divided by 3, because we can do whole number with whole number, will cancel out. And then our final answer is going to be your square root of 10 over 6. Okay. Yep. Work out. There we go. True. You can multiply it. That's what I said. You can multiply it. You can multiply it and got 3/18, and then you reduce the 3 and the 18ths, which will give you your 1/6. Definitely, Aunt. You can do that. I'm not saying you can't. There's multiple ways of getting the same answer. Okay? I want to say shame on those teachers that says this is the one answer, this is it. No, there's multiple ways of getting the same answer. So I broke up the top to 5 and 3. Okay. The bottom to 2 and 3. Okay. Cancel out the 3, multiplies the top. Look at you. Okay, all right. Let me put that in there. She's like, ooh. I'm like, yes. Okay. So she broke up the 5 and 3. The 3 was still here. Broke up the 6 with 3 and 2. Then here, got rid of the square roots of 3's. So that means this gave me, the square root of 5 over 3, the square root of 2. But here's the thing, we can't have this radical in this denominator. So that means we had to multiply square root of 2 over square root of 2. So when you do that, you got your, I'm having problems with equal signs. You got your square root of 10. And then here, square root of 2 times square root of 2, this will give us a 2. 3 times 2 will give us our 6. Good job. See? Multiple ways of getting the same answer. Okay, same method that you used, Sean. Good. Love this. Good job. And Vic did the same thing. Nice. So the fact that you're seeing how you could break it down, you'll get it one of multiple ways. Okay? Good. All right. You guys should be proud of yourselves. I love that. All right. So so do you want me to give you one more? Or are you just like, I'm good? Love to watch this. He is only 7, but he loves math. Oh, Joe, that's awesome. So if anything, he can definitely watch it live. But if you're not against YouTube, okay, here's another option. I'd like to put that up there. Okay, you can also subscribe to my YouTube channel, Audrey Codner, ACG Math Tutoring. So you guys can take a little screenshot of this if you wish. And also, I would love for you guys, Google reviews. I need Google reviews because right now, that's how Mama is getting paid. Okay, I'm not getting paid to do this on TikTok. This is all me showing you what I can do. And if you want me as an online tutor, hey, let me know. Reach out. I have, 2 slots, really pushing, but I have 2 slots left. So if you really need me, it's close to the end of the school year. I can help with GED. I can help with AccuPlacer. I can also help with ASVAT, just with the math part, of course. But if you want, I usually put my lives, all my recordings of my lives are on my YouTube channel. So if your grandson is like, hey, let's binge watch Audrey. Says no one, but here, you never know. You can definitely take a look there, okay? All right, so yes, one more. All right, okay. So let me put this to the side. And let us see. I want to make sure I didn't pick one that I already did with you guys. Let's see, did I do this one? I didn't. And that one I did. Okay, let's try this one. All right, so we have the square root of 8 over 2, the square root of 7. Okay, I'm going to leave you alone with this. We're going to check our answers in, let's say, like a minute and a half. Okay, so do not put your answers up. Okay, do not put your answers up. You can type it, but don't hit send. I want to give people time for them to process and see if you can give me my answer for this one, okay? Don't make me give you the teacher look. The stink eye that we have perfected. I was going to say, Michael! But it's not Michael. It wasn't you. Okay, hold your answers, which I know. It's not 5 or 6. It's cute. Let's not give you the crooked finger. You're like, I want to see how far we can push her. Okay. 2016, January 5th. Tisk, tisk. Okay. Hold your answers. Okay. So, Kita, hold your answers. I want you to answer the whole thing. Okay? We're going to release our answers in a moment. You probably just got here because I didn't see your name earlier. Okay. Okay, 20 seconds, we're going to put our answers up. No, minute's a long time. Michael! He just does it just to irritate me. All right, here we go. Go ahead and put your answers up. Let me see, let me see, let me see. Put your answers up. Okay, root 14 over 7. Root 14 over 7. 2 over root 7. I think there was like a 4 with the root 7. Hello, everyone that's coming in. Go ahead and tap while we're waiting if you would like. Ooh, that's a lot of taps. You guys were busy. I didn't even see. Hey, Pop Pop. Square root of 14 over 7. Shawnee. Okay. So we have some square roots, 14s over 7s, and we have some 2s or 4s or root 7s. So let's take a look. So I am actually going to use, what was her name? Nanya the business. Lian, how are you? All right. So I'm going to actually use your process, Nanya. Okay. So we have the square root of 8. Square root of 8 can be broken down into square root of 4, square root of 2. So that'll be my perfect prime combination. Now, the square root of 4, that actually gives me 2. So if I just put a 2 over here, just so I can save some space of us going back and forth. I'm going to rewrite my denominator. So from here, this 2 and this 2, whole number divided by whole number? Yes, ma'am, and sir. So they can cancel out, leaving me with square root of 2 over the square root of 7. Okay? So this is in violation of one of the rules. Okay? I'm doing all right. Yes, simplifying radicals. Well, actually dividing them. So this is breaking that radical in the denominator rule, right? So I have to do what's called rationalize it. So that means I need to multiply the numerator and the denominator by this radical that's currently in the denominator, because we want to get rid of that square root of 7. So, just like we mentioned earlier and yesterday, square root of 7 times square root of 7. If it's the same radical and the same radicand, that means we get just that 7 in the denominator. Okay? But in the numerator, we have a square root of 2 times the square root of 2. 7, sorry. Square root of 2 times square root of 7. Square root times square root can be multiplied, which gives me a square root of 14. Square root of 14 is going to look tempting to divide it by that 7, but no. Okay, that square root of 14 is underneath a radical. That 7 is not. Okay, so they don't have anything in common. They're together, but they ain't together. You know what I'm saying? All right, so this is your answer. Okay, square root of 14 can't be broken down because remember, it's one of those special radicals, special prime radicals. Because if I try to break down the square root of 14, I'm going to get a square root of 7 times the square root of 2. They're both prime numbers. So I'm not getting anything out of it. Okay? How are we feeling? You fell for the temptation. I know. This time, no. See, I even got your method. Always want to switch it up. That's all right. It's okay. You just multiply the top and the bottom by square root of 7. Okay. You can do that. But now you got a square root of 56, which needs to be broken down by, guess what? And it's not going to be, I think it's going to be 56. 56. Now I'm getting a brain fart. So 56 will be 4 and 14. Okay, so we can do that. So let me put that in, I don't know, green. So like if you did it this way, multiply this by square root of 7, multiply this by square root of 7, you do get the square root of 56 over 2 times 7. Okay. And like we said, square root of 56, that's going to be the square root of 4 and 14. So now you have 2 times 7. Square root of 4 gives me 2. So I can cancel out the 2's. And I'll just get my square root of 14 over 7. Okay. Yes. So all you had to do was just break down the square root, or see if you could break down the square root of 56, which we could. And then try to reduce that way. All right. Ladies and gentlemen. Oops. All right. Well, you guys, are you going to teach factoring polynomials? Oh, Kathy, you are in my brain, girl. That's what I'm going to do tomorrow. She's like, ooh, yes. I'm glad I found you. Oh, thanks. So, yes. She's like, yes. That's what we're doing. So, yes. What time tomorrow? That's when it gets kind of complicated. Because I definitely go to church. Oh, wait. I have a cancellation. So, if anything, follow me. If you're not following me, follow me and hit the notification button. because it might be in the evening. It's not going to be early in the morning. Definitely not. It might be. If I do 1 o'clock, I have someone at 2. So I could go at 12:30. That's one option. And this is Eastern Standard Time. Or I can go at 3:30. From 3:30, and I have to leave at 4:30 because I have to get myself ready for church at 5. Okay. But evening sounds better. All right. I can do evening. I'll probably just do my usual 7 or 8 p.m. Eastern Standard Time. I can do that. Okay. So evening will be better. Awesome. I need to put an alarm on. Okay. Taking college algebra and struggling with factoring. Oh, well then come on in tomorrow. And then guess what? If you guys can't and you forget, okay, so I'm going to go tomorrow evening. But if you forget, remember, I'm going to upload the lives on my YouTube channel. Here I go again. Okay, so you can subscribe here. Follow me here. Subscribe me at YouTube. All right, hit the Google. That would be awesome. Yeah, I think it's going to be like around 7 or 8 on Saturday. Depends on how lively my preacher gets. Well, it's after Easter now, so he might be slowing down a bit. Sometimes they just be doing too much. Like, all right. I caught how many times you had to catch the Holy Ghost? How many? Now we just being crazy with it. Because sometimes, look, I love the Lord, but I know you didn't catch the Holy Ghost like 5 times in like 5 seconds, right? Come on now. All right, come on. Okay, so thank you guys so much for the taps. Now, here's another thing. If you like how I set up my notebook, I created this notebook. Yes, me. All right, so I really had like teachers in mind if they want to check the mood, like do a little mood checker for their kids. It's also great for homeschool parents as well. We're a place that you can put your formulas down. Here's a section for your formulas and a section for your steps. So it just kind of helps to organize everything. And where I am still, I never knew it was going to be this treacherous because I'm actually going to sell my notes online, and right now I'm putting the videos that are associated with the notes to make sure I got the right videos or the right spots. Yeah, I never knew it was going to be this huge ordeal, but here we are. But it's just a great way of just putting all your notes together, and at the same time, and you've probably seen a couple times today, we have our factor sheet. Okay, so if you're looking for a factor sheet, and my factor sheet goes from 1 to 200, okay, because this book is really designed for 7th grade all the way up to adult learners, because, a lot of the notebooks that are out there nowadays is really designed for elementary or pre-algebra. So I also have like your rules for integers here, what are the most used words for word problems, formulas for linear and quadratic equations, order of operations, properties of exponents. We have the SOHCAHTOA, we have Pythagorean's theorem, and some of the identities for those advanced algebra 2 kids. Then we have volume and surface area, the area of the sector, the arc length, area of the circle, the equation of the circle. I think I might do like a little side. I'm not sure if it'll be alive, but I'll see if I can do something for the equation of the circle and ellipses, because I know there's a lot of students that are working on that now, because I've been working with students with that, as well as the unit circle. So, and then I also put a little bit of brain breaks, because sometimes we just need a little bit of brain break just to kind of break the monotony up. But it's like 100 pages of the notes where you have the dots on one side. I like the dots especially for graphing. And then you have the grid on the other side. And I'm actually working on so you can put like more sample problems. If your teacher ever gives you a paper and they say, okay, leave it in your notebook, you can tape it to the grid side, and then you can use this dot side to summarize what that paper is. Okay. So yeah, thank you. Yes, it really is golden, because especially the resources. A lot of my current tutoring kids love this part because they don't know how to read a multiplication table. The struggle is real. Okay, but they get this. So if you are interested, you can go to my Amazon. You could type in my name, Audrey Codner, in Amazon, and it'll pop up. Or you can click on my picture in the profile, go to Ultimate Math Notebook, and you can just click on the link, which will say book on Amazon. It'll take you straight to Amazon and you can order it there. I am working on self-publishing. Trust me, it is not as easy as everyone thinks it is. All right, so I'm working on the self-publishing part. But here are a couple people before I let you guys go. If you are thinking about going to nursing, a blessed RN will be your best bet. She has a way of doing the dosage with very minimal math, but at the same time, very accurate. Then if you want, right now, I think my girl Evelyn on Impact Math 19, she's going on right now. If you want to do some more math with her, she does the T-test, the ASVAB, the GED math. If you ever want help with chemistry, at 10 a.m. Eastern Standard Time, Professor TK is live and direct, and I think she'll be on later on this evening. And then my friend Learning with Nanette, if you ever want to learn how to add, subtract, multiply, divide with an abacus, she is really changing the game right now. I really want her to blow up because she is amazeball. Okay, good. Yep, so let me know. All right, so I'm going to let you guys go. Go ahead and go to Impact Math 19 if you want to do some more practicing up. And then I'm going to go into factoring tomorrow. Basically, this weekend, I'm going to be doing factoring. So because after that, we're going to work on rational functions. And it'll be best if you know and understand factoring before we get into that. All right, cool. So I'm excited. So I will see you guys tomorrow. Have a lovely day. Stay safe. And I'll see you tomorrow night. Okay. All right. Thank you so much for the likes. Ooh, 16.8. Oh my goodness. And there's 55 people in here. Ooh. Am I back tonight? Yeah. I don't know if I'm going to be back tonight because I really need to clean my house. like it's starting to talk to me. Like, lady. I need for you to vacuum. Like, come on now. Like, you need to get your life together. Okay. Yeah, so I'll see you tomorrow, Michael. All right. Have a good day, guys. Take care. Bye now.